I get really annoyed when people use up my question time to promote their thing, so I'm going to use my talk time to promote my thing. So quick announcement. The NASA money for U.S. early career people came in last night at 10 p.m. so they actually delivered the money before the meeting ended. If this describes you, if you're a NASA, if you're a U.S. Graduate student or postdoc, and that does include NYUAD, there's some funding available to support travel here. We're going to cover the Ray's fee waivers first, because he did that out of his personal research funds, which, Ray, that was crazy, but that was crazy nice. The important thing is don't send your receipts into your university for reimbursement, because you can't get reimbursed for the same thing twice. And I will follow up in an email early next week. Okay. And then also, there was a bunch of stuff this morning about needing more measurements in the lab of various things. We just hired 2 new faculty. Carrie Donaldson Hanna was just hired this year. Chris Bennett was hired a couple of years ago. And they do astrochemistry, spectroscopy, surface processes in the lab. They'll also do some things that are not straight up on the surface. So if you want it produced and measured, talk to them. And our website is planets.ucf.edu. And finally, if you didn't sign up for dinner either, talk to me. Okay. All right. So I put up this slide in my when I brought this topic up on Monday. So the SETI community has this scale that they developed in Rio in 2005, updated in 2018, and they call it an excitement level, which is maybe not an inappropriate thing for their topic. And their formula is R equals Q times delta, and Q is the consequence of the signal, and delta is the credibility of the signal. And we kind of, in our discussions this week, we kind of have stuck to that much of their scale. We pretty much threw out the rest of it, but maybe that's, well, we'll continue to talk about that. So the other thing, and we didn't talk about this in our breakout meeting the other day, but I have talked about it a lot with individuals. People seem to like this kind of language for the description of new observations. So if you've got, if you see something and you're announcing a discovery, you call it a speculative signal. And once it goes through the process of having, increased verification and demonstrating that it's not instrumental and so forth, you can start calling it things like, a verified signal, a candidate signal, and an actual discovery. Those conservative words prevent us from overhyping. And really what it does is it prevents the media from doubly overhyping your not very overhyped press release, which they like to do, or at least some of them like to do. A process keeps the public engaged in what we do longer. So if you say, I've got a speculative signal, and the next step is for somebody else to go look at it and verify it, then people know that they're maybe going to hear more about this. And then finally, that discovery is something that the field does when science works and we have consensus about a result. Okay, so these are the questions I put up. Should we adopt these terms was the first question. I'm curious how people feel about that. So let's do a show of hands. If you like that idea, meaning like it well enough that you're going to do it in your own press release, call your own press release speculative on the first go. Let me see how many people feel good with that. How many people don't feel so good with that? Okay. How many people aren't sure? All right, now how many people didn't raise their hand? No, anyway. Okay. So I see not consensus, but certainly a lot of interest in terms like that. So maybe we can find some terms that aren't quite so derogatory, but maybe also don't call something so exciting on the first go. All right, as far as I know, at this point, there is not yet a scale for this in the works. There was mention of a paper by Dave Catling, which is a nice description of how to do Bayesian analysis on biosignatures. So that's part of what we're interested in, but it doesn't talk about things like needing multiple observations or whether the signal might be confused for something else. I guess we're making a scale. In our discussion, we kind of decided the details of Rio 2 were a little bit too complicated for us. And I think that might be possible for them because they've thought a lot about specifically the kinds of signals they expect to see. And it's a pretty much narrower range of, I think it's a narrower range of ideas than the kinds of things that we are talking about for non-intelligent life. So we didn't like the complexity. We stuck to something a little bit more conceptually simple. So we developed a draft scale, which I'll show you shortly, and bring it back here for discussion. I don't know if we're ready to vote on something, but at least we'll ask if people think it's a reasonable idea to proceed with. The next step is to develop a paper and a website, and the website's important because the paper is going to talk to our colleagues. The website's going to talk to the press and people who are reading stuff and wondering what this scale is and so forth. So that website is probably as important for the success of this thing as a paper. If we just publish a paper, it will dive into some journal and never come out. If you're interested in joining us and you haven't yet, please send me an email. I'm jh@physics.ucf.edu. And of course, I put that last, which means I better wait 11 seconds for people to note it. Maybe I don't have to wait a full 11 seconds. Okay. All right, so this is what we kind of came up with as a ballpark thing. And the key item for us was a great idea by Peter Wheatley, which is that if you don't have some ones periodically, people will forget that you exist. And I think that's the problem with Rio. It's so hard to get a 1 in Rio that I don't know that it's ever happened. And so as a consequence, Rio in 2005, there were maybe some discussions at some point and people talked about it. And then people kind of tended to stop using it. So on the other hand, the Torino scale for asteroids, they've got 4 or 5 asteroids a year. There are a 1 on their scale. So people keep using and hearing about their scale. So we decided a 1 would be a place that life could exist, like you don't automatically rule it out, like a terrestrial planet in the habitable zone. And I know we have to go argue about what the habitable zone is, but that's all sort of part of the process. And a 2 is maybe a place where life should exist, like an ocean. So maybe you've got a specular reflection or something like that. You have evidence for an ocean that would be pushing it toward a 2. 3 or 4 would be an individual biosignature, and you would go 3 or 4 depending on how convincing that kind of biosignature was in the community. 5 to 7 would be multiple independent biosignatures, and this really damn good biosignature would be 8 to 10. That would be something like a high-resolution spectrum of a molecule that can only be produced by life. And I don't mean like phosphine, I mean like chlorophyll. And then we had a question, all right, what if you found CFCs? Okay. So if you can convince us that CFCs cannot be produced naturally, then CFCs might be something in here, but they would certainly be something in there. And so, and with CFCs, maybe it's something in here, and then you call up your SETI friends and say, go look at that planet. And then maybe they'll come back with some additional lines of evidence. We did not talk quantitatively about signal quality. We pretty much spent all of our time on the scale, on the signal interpretation scale. But we did have some general agreement on some items that we want to see in a highly rated signal, like multiple observations, multiple analyses by different teams, multiple instruments, reliable or respectable methods or instruments. So if you're talking about, a 10 ppm result with Spitzer, no. But perhaps with other telescopes. Standing the test of time, so there's time for people to come up with alternative ways of interpreting the data, alternative ways of analyzing the data. And so perhaps we'll end up with a 0 to 1 scale that multiplies the other scale, because everybody likes 1 to 10. So this is the Torino scale, and you'll notice that it's got these sort of diagonal zones. So as your level of concern increases, the level of probability that you care about drops. Here's what I'm sort of a quick graphic I made out of ours. And so your 9 and 10 are up here. That's 0. Here's 1 and 2. So this is the scale I gave you before, or for the significance of the evidence, and this is the quality of the evidence. This is that last slide where we maybe go from 0 to 1. So if you've got a really firm detection of a terrestrial planet, you're a 1. And then if you've got a really firm detection of a single biosignature, it's going to be in this range. If you've got kind of a weak detection of a single biosignature, you're probably still a 2. And maybe the curvature or exact placement of these curves get shifted around, but that's the general idea. So next steps, quantify that signal quality scale and how we combine the two. Obviously, we need to involve some more biosignature experts than we currently have, which is approximately 1. It's been suggested that we include a philosopher, some press officers, and some press people, just to see that this could actually be used. Evaluating examples independently, coming up with if I had a such and such quality observation of this particular biosignature, how would you rate it? And give that to a bunch of people and see that you can actually use this rating system consistently. Would certainly be something we have to do. They did it for Rio. Rio did a bunch of statistical tests, and so we may need to do that. And then finally, coming up with a website, examples, a bunch of popular level explanations, and everything has to be an app, doesn't it? Okay, we publish it, and then that's actually not the end, because then we'll actually have to catalog every claim on the site. On this website, we would have to actually, not just assume that people are going to use it, but go after people who didn't use it and say, hey, could you rate on the scale? Encourage media people to ask that question, right? You get called up as an expert and say, and one of the questions you're going to get is, hey, these guys, made this biosignature. What scale rating do you give it? And then I threw in here, because these are going to go up on the ExoClimes website. I've just thrown in here the papers that we've been talking about so far. So for the original Torino scale, this is the Rio reference, or the couple of Rio references. There's an in situ scale that we found, the ladder of life detection, which includes a bunch of NASA executive people and some people that probably actually did the work. I don't know this paper, so maybe the NASA execs also did some work. But this is for in situ measurements of life in the solar system. And then finally the Catling paper. And there are actually a pretty good number of Wikipedia and other popular articles and sites and so forth, which I didn't catalog. So I will go back to there and open for questions. Go ahead. Kimberly. Oh.
Yeah, in addition to biosignatures on the scale, I wonder if we should include pre-biosignatures, that is, signatures that prebiotic chemistry is actually happening, things like HCN detections and other prebiotic molecules. HCN detections in a habitable zone planet would get you up to maybe like a 1.5 or something.
Yeah, I mean, so an ocean wouldn't be the only way to get here, and neither would a terrestrial planet be the only way to get there. This is sort of the weight of the evidence is like you've got a rock that might have the right temperature, and then you've got some things that we think should be there, and maybe something like a prebiotic chemistry would be in here. Although I think anything that can be explained abiotically would sort of not convince anybody. So, there's HCN supposedly, and some of the hot Jupiters. Maybe that's too hot. I don't know, but yeah, I want to be really clear. This is not these are absolutely not the only ways to get there, right? These are just examples of ways of moving on the scale.
Hi, Kim Bott, University of Washington. I just wanted to bring up a few bookkeeping things. First of all, I love this idea. I love where this is headed, and I've talked to you about this a little bit. But I would implore us to open this up to the community even more and make sure that more of the community is hearing about it.
Absolutely.
I love ExoClimes because it's fun. I get to meet all of you, but there's very few of us here. So maybe, I don't know if we can talk about this more at like AAS or something and like make this more public in the meantime. That would be really great.
Absolutely. And
that would ensure that the community would use it. Also, bringing in a philosopher, I heard some people scoff at, and I like the idea of bringing in a science historian. There's a lot of insight that those kind of people with those backgrounds can give us into like how to not screw this up and totally miscommunicate with the public in ways that have been done before. And lastly, just to think about the balance of the science impact, and you kind of touched on this, not getting too bogged down with the methods because we may not anticipate realistically how we detect these biosignatures. So just kind of broad scale ideas I wanted to bring up with you all.
Thank you. Yes, I fully, yes. So.
I also think it's a great idea. I have a question regarding the point 2 and 3. Well, okay, actually, point 3 and 4. So the second one that says a place life should exist, example, an ocean. It could be, I think, an amazing thing to discover and say that there is an ocean in such a planet. And maybe the way that the field is going now, it might be easier to detect biosignature in the atmosphere. So it kind of, this doesn't reflect the relevance of such a discovery. And I'm a bit, maybe we can discuss about that.
I don't think you need an ocean to get to 3.
No, I mean, if you look at point 2, you have place life should exist and is written an ocean. And then 3 and 4 is the detection of a single biosignature. And I kind of think that the relevance of a discovery, like you might give it a 2 and then the people will think this is not relevant, but actually it would be an amazing thing to have. You know what I mean? We can discuss later.
Yeah, I'd be happy to discuss. I think the reason we made this one before that one is that, well, I don't know if you have an ocean, do you automatically have life?
No.
Maybe I don't. Maybe you know. But these things being called biosignatures are being called that because that's supposed to be the only or the principal place you can get that from. So this is less believable as an indicator of life than that. If you get this without that, great, jump right to 3 or 4. If that's not convincing, then I don't understand your point.
Okay, we can talk later.
Okay.
Regarding the catalog, is there a plan for like community verification of submitted possible biosignatures, sending it out to a mailing list or something and getting everyone to say, yes, I agree, this should be a 5 or 4 or...
The way the other scales are working is that everybody makes their own evaluation. And the reason for that is the press doesn't want to wait weeks for you to go and have your committee meeting. So you say in your press release, we think this is a 3. And they go and ask experts, and the experts say, yeah, I agree this is a 3. The experts say, no, this is only a 1. And even that disagreement, if it is a disagreement, is indicative of the quality of your signal and your biosignature.
It'll be Stephen and then Jane.
Would somebody get a mic up to Stephen?
2 quick points. Firstly, my understanding is from the Rio scale is that, like you said, they rarely get high numbers at all. But that's not because they can't right now. It's just because the criteria are harsh. Whereas with this criteria, some of those are actually inaccessible to us for the near future. So that's going to naturally truncate it. So, but the other point is that for point number 1, I mean, one of the issues that I tend to rage about when it comes to the Hubble zone, because I work on the Hubble zone a lot, and when we use phrases like Earth-like and temperate planet, then there's a suggestion or there's a claim there about the knowledge of the surface conditions which we can't back up. And so unless we include a constraint on using those kind of phrases in our point number 1, then we're going to continue to have the kind of hyperbolic press releases that we still have.
That's a very good point. And I think, so maybe what we need to do up here is get specific in the things that we're actually already having. And then as time goes on, we'll need to do that in these other categories. And these scales tend to get revised as science progresses. And so I think we can probably, although I fear the argument, but we can probably do something that's a little bit better than what's just written here for item 1 and possibly even for item 2. And then I have no idea what we would do down here, but I don't really care, because if we can, I doubt that in my lifetime we'll have a high resolution spectrum of a molecule that's complex on any planet outside the solar system. But so that's I think progressing our specificity as time and technology reach the various points is probably what we need to do there.
All right, Jane, while we're setting up.
Yeah, this is just to follow on from Stephen's first point that, as an observer, I look at this and I think, we're not going to get past maybe a 1.5 for at least 5 years, maybe 10 years.
Yeah.
And so I wondered if in your sessions, if you discussed the timing of when you would want people to actually start using this scale in the press. Do we want to do it immediately and report once for the next 10 years? Or
I think so. I'm not afraid of having low values for a long time because everybody knows that the detection of life is a big deal and not necessarily happening this year. And on the flip side of it, this is the kind of thing that might get taxpayers to say, I really would like to see a 5 or a 6 or a 7. And they tell us that if we build this telescope, we'll get it. And so let's do that. Mm-hmm. And so it might be the kind of thing that we can use as a funding argument as well.
Mm-hmm.
All right, let's thank Joe again.